Yeah, we're live, 10:45. Look at that. Just throw the rhymes out there when you're not even trying. I hope everyone's having a good day. So, again, it's morning time. So, we talked about your project motivation, your morning motivation, get your projects done. So, get out there and get your projects done. I've got stuff I've got to be doing. Yesterday was was working on the car day. I had to put the front brakes on my wife's Mercedes. It just pads. But today I've got to redo one side, not redo it. I just have to, excuse me, I have to put, there's a pad sensor that goes on that car. Which is the first time I've done one of those, but it has a little sensor that they stick down the groove of the pad. So when the pad wears down too much, it's just a wear sensor basically, but that breaks when, when the pad wears out too much. So I've got to go get another one of those and just replace that. It's pretty easy. And that way the check brake pad light will go out. But, that's all part of the deal. But today we want to talk about the L78, the 396. I'll go ahead. I'm going to bring that photo up so you guys can take a look and see what I'm talking about. Don't you? Let's see. Downloads. There's our photo. So this is the thumbnail photo for the guys that are here taking a look at it. And what that is this is the 396 on the dyno prior to startup. And what we do is we've got a tool that goes down in the distributor hole and engages the oil pump. It's an oil pump drive basically. And then we use this electric drill, spin the thing up. You can see back here in the background, back here, we've got an oil pressure gauge. And what we do is spin the drill, and then obviously, hopefully, we get oil pressure. We did right away. And then what I do is we keep spinning that until we get, these are all the rocker arms. We have the valve covers off. We spin the drill and rotate the motor, usually by hand. Well, always by hand. And I never use the starter to do that. Rotate the motor by hand without the plugs are not in it. And then I rotate them and keep the drill going with pressure in there until we get oil up through all the lifters and up all the push rods and then coming out the rocker. So as soon as we have oil to all the rockers, we know that, hey, the whole thing is getting oiling when we pre-lube it. And there's a lot of this footage that I didn't put in the video. I have two phones. So I shot some of it with my other phone. And when I was doing the editing and stuff, I didn't look on that other phone for all the footage because I thought that all the footage was on one phone, but it was not. And unfortunately, it was some of the important stuff like doing the pre-oiling, which is very important, obviously part of it, because it's something that we do on every motor that I put together. We don't have to do that on junkyard motors because they've already run. But if you're putting together a brand new motor, I got some funny comments in the video or about the video. That I put it together dry with no oil and all this stuff. I'm like, it's really after 30 plus years, it's really not my first time. And not even that, even before that, when I was doing stuff that wasn't like magazine related or West Tech related or whatever, it's not like you don't know how to do that. When I'm putting the motors together, sometimes I'll use assembly lube. It usually depends on, like on the bearings, on the main bearings and rod bearings. Sometimes I use assembly lube, and sometimes I use oil. Usually for me, if I'm putting the motor together there at West Tech and we're going to then put it on the dyno, which I did on this 396, it just took 3 or 4 days of working and not getting paid to get the motor together and get everything assembled, get all the parts and find things and go to the store and do all the stuff that you have to do when you're putting these together. It would be nice to have everything laid out and you have everything you need and you're just assembling, because all the measuring and stuff would have already been done. And we did that. As it turned out, I had to, when I was doing the thrust, we measured the thrust. It was about 3.5. Might be okay for an automatic application, but not for a stick. So what we did was sand down the thrust surfaces of the bearings till I got about 5.5. And you hit it with a mallet or we use a a brass drift on both sides of the crank and move it back and forth, and then tighten everything down, and then so that you square up the make sure that the thrust bearings are squared up and stuff, and then you measure it, and then that way you usually sometimes by tapping on it in either direction you can get another half hour or so, but we wanted more, so we got 5.5. And then when I assembled it, I used oil because I was going to run it right away. As soon as this thing went together and was complete, I was going to put it up on the dyno. And then before we run it, what we do is, like I showed in this photo, we'll take, and we have an oil pump primer tool, basically an old distributor with a shaft. And when we slide that in, engage the oil pump, and then we lock the drill onto the shaft, and then we spin we fill it full of oil. And you saw on this one, this is an older 67 block. So we use a canister style filter, and then we put an adapter on it to put a spin on filter on it. And then we fill it full of oil and then prime the oiling system. And then right away, because we have a line going over to the dyno that shows the oil pressure, we see, and before, so we can backtrack this a little bit. The other thing I might not have showed on there, I did show in the video, we made sure that the depth of the oil pump pickup was right for that pan. So we had about 3/8 of an inch or so between the closest point of the pickup and the bottom of the pan. And then we, because you measure it with clay and stuff and put the pan down and all that. And then after tapping the pickup into the pump, because they come they come separated, and then after getting it in the right position, I then took and tack welded in place so that it wouldn't wiggle around and come off and fall into the pan, which I've seen happen actually. But then before putting the pump assembly together and bolting it on the motor for the last time, I used assembly lube in the pump. Use assembly lube, use the oil pump drive, spun the oil pump drive, get all of the gears basically coated with this stuff. And when you use assembly lube in there, usually it grabs oil immediately because it's sealed, and then it has a good tight seal and a vacuum, and then it'll draw the oil up. And it did. As soon as we hit this thing with the drill, we had oil pressure immediately, and we had about 75 or 80 pounds of oil pressure cold on the drill, which was good. And then, like I said, we ran the drill until we have oil up to all of the rockers. And sometimes, some of them, it took a while to get. One side got it before the other side, and the other side got it slowly, and you just got to move it around until you get it in its happy spot. And once you get all of them going, and you let the drill off and there's no more oil flow, and then you hit the drill again, then it immediately comes out. So it wants to, as soon as it's all happy and flowing, then everything's good. And then we adjust the valves again, and I had adjusted the valves before we put it on the dyno. We just adjust the valves again. And the other video that I have, video clip that I have in there, is with the motor actually running, because it ran on the dyno, and this is something that may have not have been evident on there. The motor ran, it was broken in because we broke in the cam. When I put this flat tappet cam in, which was a performance cam that we had laying, a really old one. That camshaft had probably been laying there for 20 or more years in this box, because nobody ever used it. Nobody ever used this like Magnum, upgrade cam for the factory solid flat tappet cam, because we had long since gone to hydraulic roller on most things. And we wouldn't have used a Magnum cam because it's a single pattern. Although this one was not a single pattern. We wouldn't have used this camshaft. Nobody would have tried that. We would have used something, a more modern design. So this thing has been sitting there for a long time, but I was expecting the exact duplicate reproduction from Elgin. It just didn't come in time for me to get this thing assembled. I was in like, let's make it happen mode, and wanted to get the motor assembled and run on the dyno. that was for that trip, that was going to happen. So I grabbed this camshaft and I thought, well, I can break it in and run it on this camshaft because we have enough spring rate to do that. I can run it on that camshaft, and then we'll take it back to stock. So the idea for this build is to run it in as stock of a configuration as I can, which means we're going to run the stock cam in it. We're going to run the stock rockers on it, which I also put the Magnum roller tip rockers on there. Again, only because that's what we had at the time, because I wanted to get it run and get it on there. And I put a Brawler carburetor on there. We'll try to run the Holley 780 on there, and maybe a couple of different carburetors. And I have a set of stock exhaust manifolds, which big block stock exhaust manifolds, which we'll run because we want to see. We have somebody here that I think from Sweden or Norway or somewhere that was recommending that we try to use the actual Corvette exhaust manifolds because they are better. But if we run the stock exhaust manifolds that I have, whatever they are, I don't even know what they are, and then run headers, the Corvette ones could be between there if they are better. In my opinion, what's going to happen between a stock exhaust manifold and another stock exhaust manifold is going to be about the equivalent of shorty headers. So the gain that you get from one stock exhaust manifold to another, unless one of them is like ultra restrictive, like the Magnum or like the Dodge Ram, the Hemis, the truck ones, the truck manifolds are not very good. The SRT8 manifolds are quite a bit better. But the manifolds that we have for the big block are not like that. They're not like ultra restrictive. So anything that we have, a variation between any of the stock exhaust manifolds, is not going to be great. It's not going to be as great of a difference as between a stock exhaust manifold and a long tube header. So it will be skewed more toward the other stock exhaust manifold if we do the Corvette one. The problem is finding Corvette numbers matching exhaust manifolds or Impalas or any of those that we would use that exhaust manifold is difficult and expensive. I'm not going to buy them just to run them on a test and then go, well, now what do I do with them? Do we just throw them away or put them on the motor, I guess, to sell it? So I won't do that, but I will run stock exhaust manifolds and we will compare them to headers. So we'll see what happens there. But it will go together all stock. Some people had mentioned when you look at I showed photos of the intake manifold and they had been blued to see, not because those were ported, obviously. They're not ported. He was just doing it to make sure that when he surfaced it, that it was all surfaced correctly. So there's the manifold is stock. It does have an MSD distributor on it. I'm trying to get a points distributor so we can run that also and get it as stock as possible. I honestly don't think we're going to see a difference between the two distributors if we get the dual point or if we get the points distributor dialed in. I don't think you'll see a difference between an MSD electronic ignition and the other ones in terms of power. But we'll try it. Somebody had mentioned the springs. We had put a spring package on there, or James from Bostic Racing had put a spring package on there that allowed us to actually go up in cam size, so we could run this camshaft that we have in there. That's good because I would like it, and I don't think I would put together a motor to be run for any length of time with a stock set of valve springs in it because they're just not very good. They obviously worked back in the day, but if you were going to constantly rev this thing, you probably would put better springs in it. And especially if you're going to run other cams, there might be a slight difference in power from the springs as I showed in the valve spring video. If you haven't taken a look at it, you can take a look at it. As we go up in spring rate, you lose a little bit of power. I mean, you're having to compress more spring. That's not unusual. The difference is very, very minor, but the safety margin is much better with proper springs. And then also when we did this break-in initial thing, we ran through break-in cycles because this was a flat tappet cam. I put a heavy dose of assembly lube, moly-based assembly lube, on all the cam lobes and on the bottom of the lifters, and then we used a high zinc break-in oil. And I took the inner springs out of the cylinder heads and broke it in that way. So the other thing is that I didn't show in the video. At least I should have showed the motor running so you could hear it. But I didn't, and I should have. But this thing will obviously go back up on the dyno with everything right and repaired. And then we will also try it with the stock cam and with this cam. We'll try it with stock exhaust manifolds and headers. We'll try it probably with a couple of different carburetors. I may put these roller tip rockers on to see if they do anything. Maybe the ratio of the rocker is truer with these roller tip rockers. The other thing that this had that was not stock were um, the guide plates. They were adjustable, but again, just we had them so that we could line the rockers up. I actually would have just as soon put stock guide plates and things on there because it had been easier ultimately to do the adjustment, because when you have individual adjustments, then you got to go through each one individually and do it. When you have a guide plate that's locked together, all you can do is rock it one way, a little bit, and just kind of get the best compromise between the two that you can. With an individual one with the adjusting nut in the center, you can get both of them so that it's kind of true on the tip. I don't know if that's worth any power, but we'd have to see. The block did not require a grooved cam. The 67's later, so that's only on the earlier ones. So we just run a conventional cam in it. It didn't have to have a grooved cam or bearing set. What else? I used I did gap all the rings. I think I put them at 3, 5, 15. I don't know, 22 thousandths or something. I think it was about 5 thousandths per inch of bore or something. Not boost ready, obviously, because this thing is never going to see boost. One thing I kind of wish I would have done that I didn't do is I wish I would have polished all the pistons, but I just wanted to get this thing done. At least knock all the edges down. The edges didn't feel too bad. And the other thing I did is I use I think it's a 1017-1. The head gaskets that I used were for a much bigger bore. They were for like a 4 or 500 bore, so they were much bigger. So we need a like a 4 380 bore head gasket, which we'll put that on too, because then that will change the compression a little bit. So all that stuff is planned, and I'm gonna I use stock head bolts. I think I'm gonna put ARPs in it. Right now I just have a regular bolt holding the oil pump on, but I want to get an ARP bolt or a stud on that. This has some kind of a stock pan in it that does have a baffle, but there's no windage tray or anything in it because this motor would not have come with that. It does have a double roller timing chain. Somebody had pointed that out. Oh, that's worth a lot of power. No, it's actually not. Unless the chain has slack in it. If you put a brand new chain in it and it's a single roller, it's not going to, the double roller chain is, if anything, could cost a little bit of power, but it's not going to make any power. This chain was adjustable. I just put it straight up. Somebody said, well, did you degree the cam? Like, this isn't a build. I'm not trying to blueprint the engine, because the factory, do you know how many camshafts got degreed going down the assembly line from the factory? It's this many. None of them. They just put them on. They put them on the way that they were. So I'm very excited about this. I'm looking forward to it. And then I'm looking forward to running the next one will be the LS6. I have those heads. I bought a set of heads for those. They're very expensive. And then that will be the next one that goes together. So it'll be a lot like this, but it's just a bigger version. But I'm told that it has a more restrictive intake manifold. It's a low profile intake manifold, which surprises me in a Chevelle, because the Corvette, I can understand why it would have a low profile intake manifold because it's got a low hood line, but a Chevelle doesn't. The Chevelle has a cowl hood, and it has the cowl induction stuff. It should be able to run a good intake manifold. So I'm curious to see if that's the case in the Chevelle, and I run the low profile, the not high rise intake manifold. I'll also run a high rise version of a factory intake manifold. So it'd be good. So the poll, do you think the 375 horse 396 will make more than 425 horsepower on the dyno? Headers. So we'll see. So now I can scroll back. Good afternoon. Yamahammer 2000 series something generator. Nice. Mustang started. Oh, you started your Mustang? Cool. But I have to swap a 6-bolt flex plate. I use temporarily. You use a 6-bolt flex plate on an 8-bolt crank? That would be something to see. Big blocks are a waste of time. That's 100% not true. I was never a fan of big blocks, too heavy, and they eat gas. They do have a thirst for fuel. But comparing them to a Honda Civic VX fuel sipper, those are different things, and they're cool for different reasons. Build a 454 and only get 450 to 500 horsepower. Can get that with us. Yes, yes, we know, we get it. You're an LS guy. Big Block Chevys hate these comments. I know, it's ridiculous. People that think that one thing has to be better than another need to reevaluate. People were making comments about that, like on the 8.1. Oh, my 5.3 makes 400 and whatever, 50 horsepower, or whatever, 480 horsepower. Yeah, it does, but it doesn't make 600 foot-pounds of torque. I have a 6.2 diesel, slower than a 305. A diesel that's not a turbo diesel and one that's not hopped up with extra fuel, it can be kind of problematic. And people get to like the thing that they like. That's fantastic. You should. But it doesn't mean that the other things are bad. They're not. I live in BFE. I know where that is. I've been BFE adjacent. There aren't stores for parts. Farmers got plenty of small block Chevy stuff. That's right. You work with the stuff that you have around there. Honda Tech, what's up? Or can we want to stop in and say hi, Mike? Thanks. I agree. LS seems to run good. The LSs do run good. There, you won't find a bigger fan of LS stuff than me. But I'm also a fan of V10 Fords and Clevelands and Honda Civics. Funky offset journals on the Ford V10 was funky. Don't boost it. Yeah. Oh, I think you mean we have to boost it. What heads are on this? Or if you're talking about the 396, it has 291s. Closed chamber, big valve, rec port, high performance. Mike, the L78 with headers will make 444 horsepower. Mike's digging those fours. I don't know why you're not getting notifications. I don't know what's going on with YouTube. Jonathan, do you have any tests for a small block with high flowing heads but low compression, 8.5 to 1? It works the same way. I have I don't have small block ones, but I have big block ones, and I probably do have some small block ones. Maybe the L82 test that I did, if you take a look at that, that's probably a low compression one. But head flow does the same thing on a low compression motor that it does on a high compression motor. The compression just helps everywhere, whatever the combination. It's like boost. It just helps as a percentage everywhere, a percentage of the original power output. But if you have a big cam and lots of head flow, it still makes power way upstairs like it's supposed to. The sub 9 to 1 540-inch Dart SHP block that we did with the Dart Pro 1 heads on it, and it was low compression, made lots of power up on the big end with a big camshaft in it. and good head flow. Just tuned in, 50 horsepower just with headers. Do you think the headers will add 50 horsepower? Sandy Valley checking in. Honda Tech, you're rescuing your RX-48 from RX 4.8. RX 4.8 from church parking lot. Uh-oh. Did it run out of fuel? Your turbo center, you're pumping your oil pan dry? That's very unusual on an import motor. Does it not have enough drain back? Michael, Uncle Sam sent you an all expense paid trip to PFE. Was it jungle or was it sand? Infamous Nova, what do you think about the 502 LS? Which one? Are you talking about building one out of a tall deck deal like I did? VHP 454. I have several L78s. I have one with 12-to-1 compression, same heads. My push rods and every of my big lucks have 7/16 diameter push rods. I did have my heads extrude honed. Why are you running 7/16 push rods? Are you running like lots of spring pressure and RPM and stuff? Four-wheel drive, you had just some trick flow heads that were leaking oil past the guides on the exhaust, no matter what you did. I've had some leak water up through the surfacing that they did for the head bolts. I remember Richard running the turbo navigator motor to 1,000 horsepower. The V10 has to make more on boost. It's not gonna, because it's not going to start out making the power that the navigator motor did. The navigator motor should have made more power NA, I think. A 10.8-to-1 small block Chevy on 87 at 6,000 feet. It never pings. I curved the distributor for it. Does it have aluminum heads on it, I hope? I think something might be plugged or the block is different from the last oil pump. Yeah. That was a good motor. It was a 495 actually, and it worked well. It made lots of power and lots of torque. It could have used that's an example of a motor where it could have used a custom camshaft and not just a off-the-shelf cam. Richard, are you going to run 396 on the same octane rating as available in 1967? You don't have to. It doesn't. The octane rating is not going to change the power output. We run it cold enough on the engine dyno that it will make the maximum power on 91 octane. We can throw octane booster in it, or I can add some 100 to it just to make people feel better, because for some reason, people still think that, oh, we had like 100 octane or we had 110 octane back in the day, and it runs better on that. Yeah, it does when it's hot. It runs better, and meaning that it doesn't detonate. So if we run this motor and don't detonate it and put all the timing in it until it stops making power, that's all the power that it's going to make. Big block Chevy will blow out the push rod to rocker end even with 7/16 push rods. I don't know. I don't know why people are going up past the 3/8 push rod on a stock 396. There's no reason to do that. We already have comp 80,000 wall push rods in this, just because that's what we had laying around. 04 to 08. Okay. I know the moderators' names are blue, but what about other colors? Same names are red. Some are orange. Some are yellow. I don't have any moderators other than me. So, and I don't have any other color designations for things. Have you ever tested to see what kind of power you can make with one of these 396? This is the first 396 I've ever run, so I've never tried to do a buildup of a 396. James just picked up 2 LS 6.2 liters. Nice. You already have enough head flow to make way over 600 horsepower. So unless you're going to make these motors bigger and put lots of camshaft in it and stuff, you should just put a cam in them, and it'll be really fun in a 64 El Camino. I believe the 454 LS7 came with 7/16 push rods. Yeah, that wasn't a factory motor though. That was actually an over the counter thing. You could run a crappy tune and still keep it alive on higher octane. Yeah, you could take all the timing out of it so it doesn't detonate if you have, high compression and a dome piston that doesn't allow very good flame travel and stuff. And an iron head with a bad chamber design, which the closed chamber design is not great. Maybe it's just my computer. People's users' names have different colors. Their names do, at least the designations that are next to them do. Their icons or whatever are all different colors, but that's on their end. Be interesting to see since so many people think they aren't worth it anymore. The 396, I'm not going to do a build on the 396. I'm not going to try to make, other than putting a camshaft in it. It's going to still have the stock head and stuff. I'm not going to put aluminum heads and do all that stuff. I understand the mentality that if you're going to build a big block, it shouldn't be a sub 400-inch big block unless you're doing it for a class specific thing like at Bonneville. At Bonneville, that would be a good idea. If I was going to make a sub 400-inch motor, it would not be a small block. It would definitely be a big block because you don't have to worry about weight. So nobody cares about that. And big blocks have heads that flow an awful lot more for quite a bit less money than, like, if you were trying to get a cylinder head that flows more than 400 CFM because you're going to run it at high RPM, try to make lots of power. A small block head that flows over 400 CFM would be a lot more than a big block head that flows 400 CFM. Best cam for a stock bottom end LS3. There's no best cam, so we need to start there, and then you need to tell me what you want to do with your stock bottom end LS3. What are you trying to do? Is it a sticker? Is it an automatic? Is it a daily driver? Is it a race car? Where do you want your power? Do you have a stock converter? Let's go through all that, and I can help you pick a camshaft that will give you what you want. There's no one cam that's better than every other cam for a generic LS3. Actually, push rod diameter and thickness is a big deal on the big block. They absolutely do like 7/16 push rods, and once you get into the zone where it makes good power and spins a 6500. So we've run lots and lots of stuff way past 6500 with 3/8 push rods. And since this is a stock motor, it absolutely does not need 7/16 push rods. That's like putting 3/8 push rods in an LS. I don't understand why people are doing that. Reed, I got a Gen 5 454. What is the maximum horsepower and RPM I can run? There's no limit to either one of those if you want to spend lots and lots of money. But what would be better is not thinking it that way. What would be better is for you to decide on how much power you need to do whatever this thing that you want to do is, and then we'll let you know. You don't want lots of RPM, and you also don't necessarily want maximum horsepower. So I tell you, you can make 2,500. Are you going to use that much? Probably not. .396 has this too small of a bore. The chamber is a lot wider than the bore. It is. The chamber is a lot bigger. And I was picking the head gasket for the bore size, not for the bore size, for the chamber size, which is normally the way that you would do it. But the bore has been notched on the 396 for valve clearance. I have a 402 with 290 ovals, 11-to-1 compression, cam motion, solid roller. It's what I had to work with. Good. We do what we do with what we have. Will soon be a 496. A 496 will be basically better everywhere than a 396. Yeah, Reed, 700 or 800 horsepower with a boosted, and you don't need twin turbos, just a single turbo on there. If you want twins, I understand because twins are good, but a single turbo will easily do 700 or 800 horsepower. Put an S475 on it, an intercooler, and just a cam and add a cam and ring gap and an intake manifold to your Gen 5, and you can make that kind of power. Richard, I checked out the videos in L82. Do you have any information on just a cam swap to the 274 or just a cam and intake? Are you talking about on the L82? James, what cam are you wanting me to tell you the specs on? Are you talking about the factory ones? The chamber is also wider than the 4250 bore. I notched the bore on both of them. They notched the bore for valve clearance right on the 396. Jonathan, I don't know if I did just a cam with the stock heads on the L82. I'd have to go back and look. What's the most power you've made with a stock small block Chevy stamp rocker? I don't think I've ever tried to do that. I don't think I've ever kept the stock stamp steel rockers on there. I've never tried that. I think I do have the factory. Let's see. 520 lift, 244 at 50, and lobe separation is 114 is what they're saying. Lash is 24 and 28, according to Team Chevelle. It was hard to find parts for the 396. A little bit. The pistons weren't too hard to find. I don't think rocker arms are power limited. I would be worried with lots of spring pressure on the pivot balls and stuff. And at the very least, you got to put poly locks on to stop them from backing out. And then if you put lots of spring pressure in them and lots of RPM, I would worry about getting to the limit of a stamped steel rocker, but I don't know where that is. Small block Chevy 327 made 500 horsepower with long slots on it. I think a more appropriate question would be how much spring pressure can you run on a stamp rocker? Yeah, it's spring pressure and RPM too. I think the guys on when they were doing Trans Am, I think were running stamp steel rockers. They may have been doing long slots on them because they were running more camshaft on those. James, the 6.2s did not come with intake. Should I say factory or looked aftermarket? Do not buy a fast for that. A stock one will make more than enough power. Either the truck one, if those came from trucks, or the LS3 intake manifold, if you need a lower profile one. Those two manifolds and the ones that I've tested made identical power. Have you ever done nitrous big bang on a Gen 6 big block? No, I've only ever tried one nitrous big bang, and it resulted in in a big bang. Stamp steel rockers will go to 8,000 with 250 pounds of seat pressure and 500 pounds open. Well, there you go. Alan says that he's tested it. I know Vice Grip Garage is going through some stock rockers on a small block Chrysler during the sick week. Who did I just see did the small block Chevy stuff on a Dodge 318? Was that Vice Grip Garage? It was pretty cool. What turbo or turbos would you recommend for a stock Gen 6 454? Has ring gap, valve spring, ordered 80-pound injectors. Sure, I'll never see 5,000. An S475 is a really good turbo for that. Love to see tri-power Dominators on the trophy 4-cylinder. See if it will run. I think it would. A Dominator ran on the 6-cylinder. Any plans on stroking the 396? No. Nope. The 396 is going together and staying together. There was a conversion kit to use small block Chevy rockers on Chrysler Magnum style heads. We had to run them in stock eliminator until a few years back. The weakness is the push rod cup. Polish the burr off. Alan, does anybody ever DLC or put any kind of coating in the cup? You think the 375 horse 396 will make 425 plus horsepower on the dyno and stock trim with headers? 58% are saying yes. Do I have any experience with the stroke 396? This is the first 396 I've ever run on the dyno. Alan, do you know how much these 396 blocks can be bored? I don't know what the maximum overbore is on these 396 blocks. I don't think you can take them out to. Can you take them out to 4,250? Michael wants to know if anybody here has any experience with Hayabusa throttle bodies. I don't know that I've ever looked at them individually. The later blocks will not. So when is the earlier breakdown? $65 and $66 will bore 125. $4.09 4.094 plus 0.125 equals. 4220. In the 65 and 66 block, that has the that needs the grooved cam or the grooved bearing, right? I know 67 didn't. Chris Parker, what was the the Ford part from yesterday? It was the mass air meter that was not being used as anything except an adapter to go from big to little on the, I think it was on the discharge side. And obviously that was all in jest. That was for the LS guys, you know, throwing a little shade. Take your channel to the next level. Did the 396 change compression at all over their production years? Well, the different versions of the 396 did. But did the L78 change? Does anyone have any experience with the new Edelbrock 4150? Yeah, William, it's very, very good. The adjustability is much better than the Holley stuff. And it seems to make more power. I would highly recommend it. So the camshaft that I put in here is a good bit bigger than that factory cam. Yeah, Michael, that's what I get that stuff all the time. And they're usually with a Russian name attached to it. So let's see what they have to say. Yeah, that's definitely a Russian name. Lots of consonants. So they want to be able to dig deep into my metrics and identify causes. Yeah. Hard pass on that. Vern, the cam that Comp offers as the factory one is not the factory one. We have a direct factory replacement one. Should be there by now, I think, from Elgin. The L78 and the L6 have the same cam, and the L72. What was the difference between a 396 and a 402? 30 thousandths of overbore. And this one technically is a 402 because it's 30 over. So it's a 1970 version then, but with a 67 block. But I don't think that the 70 block is any different, other than being 30 over. What I wonder is, why did they decide to go 30 thousandths bigger on the bore? Like, I want to know what the internal decision was there. They're obviously not, I don't think that they cast them bigger and then finish machine them. I'll bet that they machined them. I bet that the block started out as the same cast bore and then they machined them differently. And I wonder if they were having core shift problems or what the deal is. Does anybody know what the story is behind that? Honda Tech, did you do anything, any underdrive pulleys or anything to that? On the 396, will you try running a mechanical water pump? I guess we could hook one up. OEM valve lash and timing spec. I'd have to look and see what we know what the valve lash is, but I'll have to see. I don't know I don't know what the curve is on a factory 396 distributor though. Any AMC plans in the future? I'd like to run one. I just haven't ever seen any in the wrecking yards. 30,000 was because EPA regulations for engines of 400 cubic inches or less. Well, this would have made it a 402, so it was beyond that. But what break did they get for something that was more than 400 inches? When will you do the final testing? After the motor gets put back together. Michael, but they didn't do it for marketing because they never advertised that. They kept it as a 396. They marketed it as the SS 396, and they never said that it was a 402. Absolutely, there's a problem with core shift, so GM punched it 30 thousandths bigger. Not sure of casting numbers, but some of the 96s were thick castings. You've never seen a straight answer on the 30,000 bore from GM? Yeah, I would. It would be cool to hear from, like, and you might not even hear that from like engineers that were working on the program. That may have just been like a higher up decision or something. It'd be interesting. I would love to hear the discussions from guys in the dyno cells and stuff. I like we get to hear some of that from some of the guys that did the Dodge turbo stuff, because some of those guys have been on the chats and stuff and talked about it. That's cool stuff to listen to them. Hey, we ran this motor for 18 hours straight or whatever, and we turned the boost up on this one. And the casting engineer was Fred Lee. He died a few years back. Two more minutes. Let's see how our. Ooh, yeah, you did fall off the table there a little bit there, didn't you? Overly built. What engine do you have? Oh, an AMC, yeah. Yeah, all of this stuff was before. That was all before my time. But it's cool stuff. Just having the inside discussions would be neat. I like hearing, about guys sneaking an engine into a car and taking it out on the proving grounds, or better yet, taking it out on Woodward or whatever, and racing guys. That kind of stuff is really cool. Because that that stuff happened. And that's the good stuff. So I'm going to go ahead and close our poll at 57% saying yes. I honestly, the way that we run it on the engine dyno, will be surprised if we don't see 425 horsepower, given the head flow and as much cam as that thing has. Making a video about optimizing valve lash and total timing versus what a guy puts in it based on an old OEM service manual would be cool to see. Yeah, if we tight lash the thing, we kind of know what's going to happen, but we can do that. We can run lash loops on it and see what happens. And also the timing, the total timing will tell you one thing, and we will adjust the timing until we make maximum power. And we might do it. I would like not to do it on a lock distributor. I'd like to do it on a distributor that has a curve in it. But the thing is, if you think about it, if you were doing a curve distributor, performance curve distributor, it would be all in by 3,000 RPM. More than likely, that's what guys did. So if we start our load at 3,000 RPM, we go from 3,000 to 6,500. It's at full advance, which in my opinion is not what it needs. But for carbureted distributor things, a lot of times that's what they had. And especially for an application where it's an iron head, high compression deal, I probably wouldn't want full timing at 3,000 RPM. If I was going to the drag strip and had high compression, it might run better like that. I thought loose lash always was better. Well, so what I want you to do is look at the word always in there and always remember that always is never the best, because there's going to be examples where that's not the case. So it's easy for it not to be. But what will happen, what normally happens when you tighten the lash up, it makes the cam more aggressive. When you loosen the lash up, it makes the cam less aggressive. What normally happens with more lash, when you loosen it up, it softens the cam up. A lot of times can make more power down low. Usually makes less power at the top. And then the reverse happens when you tight lash it. On the dyno, he claims more power. I can guarantee you that loosening the lash up is not going to make more power everywhere on every application. Pendant, you think the advertised horsepower was optimistic. The other thing is that thing isn't a universal statement. Like, the OEMs didn't lie universally about the power outputs of the motors. They did it selectively. On some things, they underrated them. On some things, they overrated them. On some things, they were accurate. So it's hard to see. It's hard to determine. That's why all this kind of testing is kind of cool. It's hard to determine which one they did which one to. The Turbo 304 dyno run is on our channel. I will check that out. That's cool. My small Chevy runs 1638 at 3,000 RPM and full vacuum at 55 rolling down the road. I don't know what 16 and 38 is. I don't know where those timings are. But if it's a vacuum advanced distributor, while you're cruising down the road, you will have a lot more timing, and you should. It gets better mileage that way. But under wide open throttle with no vacuum, a lot of times you get full timing by 3,000 RPM for a performance curve distributor. The 302 makes more than 290. Yeah, it made if you're talking about the DZ 302, it did. About to start my 468, having anxiety washing out the cam. Yeah, Roy, what we did was the things that I talked about on a new build is we put lots of a moly-based assembly lube on the cam lobes and on the lifters. We put high zinc oil in it. Normally, I also put a zinc additive in there, a break-in additive. We put break-in oil in it. And then I took the inner valve springs out to help the solid flat tappet cam break in. Overly, the for 1970 and before, and some of 71, they were a gross rating, and then after that they were net. When you run steel push rods on the VW, you run them at loose 0 lash. Once the engine expands, they will be at about 5,000 because it's an aluminum motor, right? It's going to grow. All right, get back to work. So it idles at 16, goes to full 38 at full throttle. Mopar, I don't think I've ever run EDM lifters, but the Brule and those guys on some of those motors that they've done and that the engine builders have brought in, like Miller, they've run some EDM lifters, but I haven't put them on any of the things I've done. They also changed SAE dyno testing again in 2006. They run with all the accessories. The modern factory ratings are not just with all the accessories. They're with the engine the way that it is in the car. It's not rated at the tire. It's rated at the flywheel, but it's with everything that the motor has in the vehicle. Full exhaust, cats, tailpipes, everything, stock exhaust manifolds, full accessory drives, complete air intake, run with the factory tune at the factory temperature. That's their power rating. Roy, let me know what happens. Maybe on the live feed tonight. Should multi-valve rings fit tight against each other? Yes, they normally do. They normally rub against each other. Which I've seen lots of guys, not lots of guys, but the guys from Extrude Hone used to extrude hone the springs to get a smooth finish so that you would reduce friction and reduce oil temperature coming off of the springs. Roy, that's what somebody else just brought up. Make sure that you do a break-in cycle and that you have it over 2,000 RPM. But we don't just keep it at a stationary speed. When we do our break-in cycles, we vary it from 2,500 to 3,200 RPM or so. And then not only are we cycling the engine speed, but we're also cycling the load. Crank pulley is definitely a stock unit. The water pump is a little suspect. I know that when you run underdrive pulleys on stuff, we went through this with all of the Mustang stuff, is it works fine with any kind of engine speed, but like sitting in traffic, which we used to do down at Newport Beach because we're cruising, when you're sitting, the two things that happen when you get fairly aggressive on the underdrive pulleys is the alternator voltage, the system voltage would go down, and the thing would want to overheat. Roller cam fixes the flat tab and break-in procedure. Yeah, it does. We don't even break in roller cams. We just swap cams and reuse the lifters on all of the LS stuff. That makes life a lot easier. But when we have a brand new motor, we still break in the motor just to get the rings to seat. The bearings, I'm not really that worried about. And we usually break it in at a higher temperature too. The 396 sounded good. It sounded like it had a good sized cam in it. And we went through the whole break-in procedure. I think we went through one full one. I don't think Brule did another one because he was there for the break-in procedure. Um, and he said, I think we probably could have gotten away without taking the inner springs out, but I feel better that I did. Now the head's going to go back on and will be pressure tested and everything before it goes back on. And then it will be fixed or not fixed, or I'll just replace the heads. So whatever happens, we'll have heads that go on with the inner valve spring in, and we'll be able to now run the thing. Big house. I don't break them in under a high load. It varies from about 40 foot-pounds to about 105 foot-pounds during the cycling. The only reason I wrap the throttle, we don't ever run lots of engine speed during break-in. It doesn't go over 3,500. I always wanted to ask, is that an F-18? I think it is. I think it's a Super Hornet, right? Yeah, it's an FA-18 EF Super Hornet. That's for a test that we did. We did a standing mile shootout for one of the magazines. That was a Vortec 3-valve Mustang, but we did it at Lemoore, which I think is a naval air station, maybe? Naval Air Base. Yes, Lemoore Naval Air Station. That's right. In your experience, how powerful are the Mark IV blocks? The big blocks? I don't know that I've ever tried to max one out. I know that we've done 1,000 horsepower stuff with them before, on blower stuff. I don't know how long they'll do that. One more minute. Uno minutos más, por favor. It did get real quiet. Reed Cow. Ooh, Cache Creek. By near. I gotta go. I got another video to do. I'm trying to do the revised version 2 of the Chopacabra, Chuck Norris, Cam Motion, Summit Racing, Cam Shootout. Just bought a newly rebuilt stock Chevy 307. Nice. 307 is awesome. Daniel. I don't know what a 500 lift cam could be, anywhere from 200 horsepower to, I don't know, 800 or 900 horsepower. How do you reconcile breaking in the rings on a roller cam? I don't you mean reconcile. Do I have to justify that to somebody? The rings need to break in. They need time to seat against the bores. Yeah, Michael, because it, like with the big bang stuff, it might make 1,500 horsepower once or none at all. And that's the thing. As you go up in power, you go up to a point where it will only do that one time. But as you go up, what are the delineations there? Like, it'll do this one 100 times before it breaks. It'll do this one 8 times before it breaks. It'll do this one thousands of times, because if you look at the factory OEM power level, obviously it will do that almost indefinitely. And so as we go up, it'll do lots more power and still be, thousands and thousands of cycles at that power level. We get less and less as we go up in power. I'd like to run a 307, only because I never have. Oh, how do I recommend? Okay, reconcile. So it's spell check thing. We do the break-in for rings the same way that we do it for camshafts. When we do a break-in cycle, it's usually computer controlled. I've also done it by hand. I've also done it manually. And we run the RPM from 2,500 to 32 or 3,300 RPM. And then we do that by varying the load. So we'll at less load on it, it will be at 3,200 RPM, say like 30, 40 foot-pounds. And then we add load down to bring it down to around 2,500 RPM. So that may be between 80 and 100 foot-pounds of torque. And so it's loaded down at 2,500, and then for 10 seconds or so, then we release the load and it goes back up this lighter load at a higher engine speed for around 10 seconds, and then it adds load. And I can do that manually with a load control, or we just plug in the numbers in the computer, and the computer says, okay, you want this number of sweeps in this range for this many times and for this long. And we just push a button and it just goes, wah, 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 wah. It just does it automatically. Yeah, big bang the 307. We don't need a big bang the 307. It'd be much cooler to run the 307 in a comparison to the 305 and the 302, especially the 305, not so much the 302, but the 307 would be a good one compared to a 305, because then we could talk about bore and stroke, and couldn't really talk about rod ratio because I think the rods are the same length. My dad had a 68 Camaro with a 307. They did have a 302 available. It would have been a 68 Z28. Do they have a 307 offering in 68? How about a Ford versus a Dodge V10? I think the Dodge is going to win that. It has much more displacement. Engine options. They did not offer a 307 in 68. Is what they're showing. 230, 250, 302, 327, 327, 350, 396, 396, 427, 427. But the 427s obviously were the Copo ones. And they had a 325 and a 375 horse, 396. And then a 295 horse, 350, a 250 and 210 horse, 327, and the 290 horse, 302. And then a couple of 6-cylinders. Yeah, in the Harley's garage, in the Chevelle they may have, but they didn't in a Camaro. The 307 came about in 69 as a replacement for the 283. Yeah, they don't show a listing for it on the 68 Camaro. Yeah, Butcher, the 6.8 versus an 8-liter is obviously going to have predictable results for certainly for torque. And on that note, it is time to go. Thank you guys all for showing up. Always good to spend time with you guys, but I'll see you tonight, and I'm going to be working on another video beforehand, so I got lots to do.